Hello, my name is Efetekin Güngör, and in this experiment, I investigated the behavior of a parallel plate capacitor, focusing on two main objectives. First, to verify the relationship between voltage and plate separation, and second, to determine the dielectric constants of different materials. First, let me briefly explain the theory. For a parallel plate capacitor, the capacitance depends on the plate area and the distance between them. When the charge is kept constant, the voltage across the capacitor is directly proportional to the separation distance. This means that as the plates move farther apart, the voltage should increase linearly. In my setup, I used two square conductive plates with dimensions of 2 cm by 20 cm by 20 cm. The plates were connected to a DC power supply and initially charged to 20 volts. After charging, I disconnected the power supply to ensure that the charge remained constant throughout the experiment. An electrometer was used to measure the voltage across the plates. I started with a plate separation of 3 centimeters and gradually decreased the distance down to 1 centimeter. Instead of 0.5 centimeters at each step, I recorded the voltage. The results showed an approximately linear relationship between voltage and distance, which agrees with the theoretical expectation. Next, I investigated the effect of dielectric materials. I inserted 3 different materials between the plates: paper, styrofoam, and glass, each with a thickness of 3 centimeters. When these materials were placed between the plates, the voltage decreased. This happens because the dielectric increases the capacitance by reducing the effective electric field inside the capacitor. Using the measured voltages, I calculated the dielectric constant for each material. The results were consistent with known values. Glass had the largest effect, paper showed a moderate effect, and styrofoam had the smallest impact. Overall, the experiment confirmed the theoretical relationship proving capacitors. The voltage increased with plate separation under constant charge, and dielectric materials increased the capacitance as expected. There were some errors in my calculations because of the imperfect placement of dielectrics, the plates not being that parallel, and uncertainty in my calculations. However, these errors were maximum of like 2 or 3%, so those effects were not that significant to the result of my experiment. That's all for this experiment. Thank you.